Section 1.2 covers the order of operations, which we've already talked about so far this year and should also be a review from years past. So to start, let's just review what the order of operations are. The first step of doing the order of operations is to do parentheses. So you're going to do whatever is inside of the parentheses first, and within the parentheses, you're also going to follow the order of operations. So as you know, you would multiply before you do addition if there happens to be multiplication and division inside of the parentheses. And if there's more than one set of parentheses in your problem, you're going to work from the innermost and go outward. The second step of the order of operations is to perform the exponents. So if there's any squareds or cubes or anything to any kind of power, you're going to perform that next. The third step of the order of operations is multiplication and division. So you're going to do multiplication and division, whichever operation comes first while you're working from left to right. So if there happens to be a division symbol before a multiplication symbol, you're going to divide before you multiply. The same goes for the next step, addition and subtraction. So once again, you're going to do addition and subtraction at the same time, whichever operation comes first while you're working from left to right. So just like with multiplication and division, if there happens to be a subtraction sign before an addition sign, you're going to do subtraction and then addition. So many of you remember the order of operations by the phrase, "Please excuse my dear Aunt Sally," where the first letter of each word is your clue on what order to do them. So the P in please is for parentheses. The E in excuse is for exponents. The M and D and my dear are for multiplication and division, and the A and the S and Aunt Sally are for the addition and subtraction. Or some of you remember the order of operations by using PEMDAS. So PEMDAS is another way to remember it. But the one thing that I want to emphasize on is just because the M is before the D and the A is before the S doesn't mean you do multiplication, then division, and addition, then subtraction. Remember, these are done together at the same time, and these are done together at the same time. Whichever comes first, left to right in the problem. Let's see some examples. So here's example number 1. It says evaluate, which just means to solve. So part A says 27 divided by 3 squared times 2 minus 3. So first we see that there are no parentheses. So we move on to exponents, where I see that I have 3 squared. So my next step would be to take the 3 and square it. So since 3 squared is 9, I now have 27 divided by 9 times 2 minus 3. So everything else stayed the same. I just simplified the 3 squared into 9. So now I'm going to do multiplication and division, whichever comes first from left to right. Since there's a division symbol before multiplication, I'm going to take 27 divided by 9, take that answer, and multiply by 2. So it'll look like this. Since 27 divided by 9 is 3, I now have 3 times 2, and then I'll do the minus 3 afterwards. So again, the 27 minus 9 came down to a 3, and now I'm going to multiply by the 2. So the next step would look like this. 6 minus 3, since once again the 3 times 2 was 6. So my last step would be then to subtract, since I have Aunt Sally, addition, subtraction, and I only have subtraction here. So 6 minus 3 is 3. So my final answer is 3. Let's look at another example. So here's part B. We have 2 times 3 squared plus 4. So once again, we have no parentheses, but I do see exponents. So my first step would be to simplify what 3 squared is. So just like before, 3 squared is 9. So now I have 2 times 9 plus 4. Since I have my dear Aunt Sally, the M comes before the A, so I'm going to multiply the 2 times 9 before I add the 4. So 2 times 9 is 18. And then I'm going to add the 4, so 18 plus 4 is 22. So my final answer is 22. Let's move on to another example. For part C, we have 32 divided by 2 cubed plus 6. So we have no parentheses, so I move on to the exponent. So I'm going to take 2 and cube it. The biggest misconception here is that 2 cubed is 6, but 2 times 2 times 2 is 8. So my next step would look like this. 32 divided by 8 plus 6. So now I'm going to divide before I add according to the order of operations. So 32 divided by 8 is 4, and then I'll add the 6, so my final answer is 10. And now we'll see another example. So here we see part D. It has 15 plus 6 squared minus 4. So once again, we have no parentheses, but I do have an exponent. And I would say the biggest thing that kids may mess up on is they will take 15 plus 6 and then square it. But remember, you got to square the number, and then I'm going to add. So I have 15 plus 6 squared. 6 squared is 36. So then I would just have the minus 4. 15 plus 36 minus 4. So now I'm going to do addition and subtraction, whichever comes first from left to right, since I had no multiplication and division. So 15 plus 36 is 51. So then I will take 51 minus 4 to get my final answer of 47. And again, we'll see another example on the next slide. So here we see part E. It says 3, and that would be times parentheses 8 minus 2 squared. So according to the order of operations, I'm going to do what's inside of the parentheses first. But within the parentheses, I also have to follow the order of operations. So I see 8 minus 2 squared. So the question here would be is, am I going to take 8 minus 2 and then square that answer, or square the 2 and then take 8 minus that answer? So according to the order of operations, I have to compute all of the exponents first. So it'd be 2 squared first, and then I'm going to take 8 minus that number. So my next step would look like this. 3 times 8 minus 4. So then I'm going to take 8 minus 4 and then take that answer and multiply by the 3. So that would simplify down to 4. 8 minus 4 is 4. So again, the operation that exists between the 3 and the parenthesis would be multiplication. So I'm going to take 3 times 4 to get my final answer of 12. And one last example. So here's part F. We have 2 times bracket, so that is just another grouping symbol or another parenthesis, a parenthesis 9 plus 3, and then divided by 4. So remember, our first step in the order of operations is to perform parentheses and to work from the innermost outward. So our actual parentheses in here, the rounded ones, are the innermost. So I'm going to take 9 plus 3 first. So my first step will end up looking like this. 2 times 12 divided by 4, since 9 plus 3 is 12, that simplified to a 12. So now I'm going to divide, because now my next set of parentheses were the brackets, the squared ones. So now I'm going to take 12 divided by 4 to get 3. So just like in the last example, now that I have my parentheses all simplified down, the number that is in front of the parentheses, or in this case the bracket, it is supposed to be multiplied. The operation that exists between them is multiplication. So I'm going to take 2 times 3 to get my final answer of 6. So let's look at another type of example. So here's number 2. It says evaluate the expression when y equals 8. So this time we're still going to be following the order of operations, but first we have to take this number that they're giving us and substitute it in for the variable and then follow the order of operations. So if y equals 8, I'm going to replace this y in part A of y squared minus 3 with an 8. So I'd end up with 8 squared minus 3. So according to the order of operations, I need to square the 8 before I subtract the 3. So 8 squared is 64, and 64 minus 3 then is 61. Let's see another example. So once again, I'm supposed to evaluate the expression when y equals 8. So again, I'm going to replace the y in our problem with 8. So it'll end up looking like 12 minus 8 minus 1. So there are no parentheses, there are no exponents, there's no multiplication or division, and so we skip right down to the addition subtraction part of the order of operations. And since it's only subtraction, I'm just going to go from left to right. So 12 minus 8 is 4, and then I'm going to take minus 1, so my final answer is 3. So here will be our last example. So once again, we're supposed to evaluate the expression when y equals 8, and this time we have, for part C, 10y plus 1 all over y plus 1. So again, I'm going to replace all of the y's in my problem with 8. But be careful, this is supposed to be 10 times y. So when I substitute that 8 in, I need to keep that in mind as I write it out. So now my problem will look like 10 times 8 plus 1 all over 8 plus 1. Whenever we have a fraction problem like this, well, it's really division, but it kind of looks like a fraction. There's an implied parenthesis on top and parenthesis on the bottom. So in the order of operations, we do parentheses first. So basically that just means we're going to simplify what's on top in the numerator, and we're going to simplify what's on the bottom in the denominator. So within that, we're also going to follow the order of operations. So I'm going to multiply the 10 and the 8 before I add the 1. So my next step would look like this. Since 10 times 8 is 80, I now have 80 plus 1 in the numerator, and I know I could just simplify the 8 plus 1 in the denominator, but we're just taking it step by step so you're very clear on what's happening. So now I'm going to add the numerator, and I'm going to add the denominators. So I have 80 plus 1 and 8 plus 1 to get 81 over 9, and then the last thing I'm going to do is divide. So 8 divided by 9 is 9, so my final answer is 9. That's it for this section. Make sure you jot down anything you didn't understand that we can cover in class before we move on, and we'll see you then.